Hi everyone, this is a project overview for the Turner River Flow Enhancements project. And this is essentially the same presentation given at a multi-agency coordination team meeting in Naples, Florida at the Big Cypress Basin offices on January 28th, 2014. And the idea, the goal of that meeting was to bring together the agencies that would be potentially partnering on this project. That includes Big Cypress, with an exciting opportunity to partner with Collier County to help improve the scope of the project and also defray costs. And also South Florida National Parks Trust is the entity that we received the grant money to proceed with this project. But there's other players at the table too, and that's why we had this meeting. You can't do any modification to canals or road beds without seeking approval from the South Florida Water Management District and the Army Corps of Engineers in concert with the Fish and Wildlife Service. So this meeting was just to bring everyone together to talk about this project, how to increase the rate and seasonal duration of flow to Turner River's headwater pools. So what is the issue? The issue is Turner River gets most of its headwater flow from the Turner River Canal through two culverts, and these are relatively small, undersized culverts that are 0.8 miles north and 1.4 miles north of US 41. Well, when we look at the map here, here's US 41, H.P. Williams Wayside, the first culvert and the second culvert. They're really small culverts. They're spaced about 0.4 miles apart, and there is one canal plug, that little red dot, which is a 15-foot long canal plug. So flow through those culverts, however, is small. Most of the water ends up making it south to the Tamiami Trail compared to the amount that escapes. So flow through the culverts is small compared to the amount that escapes downstream. As a result, we have these deleterious effects on the ecosystem. The wetlands on the river side of Turner River Road are underhydrated. There's not enough flow getting to Turner River's headwater pools. That's what we're looking at in the photograph. And the river channel has become clogged with submerged aquatic vegetation as a result, making really decreasing the recreational navigational opportunities on the river. Well, the simple solution is to increase the cross-sectional area of the culverts and decrease the cross-sectional area of the canal, right? Well, how do we do this? The first thing we do is we go back to lessons learned and factor in what we've discovered from previous work. The Turner River Project, Turner River Restoration Project, is not new. It started back in 1980, in the late 80s, early 90s. It was implemented on the ground. As shown in this diagram, this is Turner River Road, US 41. Anywhere you see a red dot is where a canal plug was put in. Anywhere you see a green rectangle is where a new culvert was put in. This was included in the preserve's GMP, for our original GMP, with the caveat that additional work would probably be required, which is what we're doing right now. So what type of additional work? What we've discovered is that the plugs and culverts are probably too infrequent. The plugs are spaced 1 mile apart from each other, and they're relatively small plugs, only 15 feet long, and that's the other issue. Plugs are too narrow for the low-lying swamp terrain. And finally, the plugs without culverts are only marginally effective. If you're going to put a plug in a canal, you want to put a culvert on the upstream side to get water across. That makes sense, right? And then finally, the plugs are not maintenance friendly as is. And as a result, they've eroded over time. And here's a good example in the field. It's right next door in Burdon Road. And what we see is during the wet season, here's one of our plugs. And water is easily bypassing around the plug. And there is not an upstream culvert. And that's, summers include water easily bypasses around the plug. Erosional channels decrease the plug's effectiveness over time, where the water is flowing is a deeply rutted channel, and there's no water being sent on the other side of the road. So a partial solution would be to just make this plug longer. And in fact, such an example already exists. It's on Turner River Road, about 2 miles north of H.P. Williams, and it's about a 140-foot long plug. However, this plug needs a culvert on its upstream side, because absent that culvert to direct the water that's stacked up behind the plug, the water just rises up and flows down the middle of the plug, as seen in May 2013. So the wet season had barely gotten started, and we're already losing water down that plug. So when water has no place to go except up and over the plug and down the canal. So what is our lesson learned? Here's our second culvert, 1.4 miles north of H.P. Williams. We're looking south. We want to, for this project, adopt a culvert plug pair as our standard treatment. So here we just have a culvert. We want to put a plug in there too. So we're going to put a plug in there, and when we do that, we direct more water into the culvert. And we want to make the plugs longer. We're aiming to put 150 feet or longer, and put them at wetland grade. There's no reason to put these plugs any higher than wetland grade because it's a low-lying area. You really, water bypasses around the adjacent wetland. So we want to keep everything the same there. And we want to place culverts on the upstream pooled side of plugs where no culverts exist. And we want to increase the frequency of culvert plug treatments where possible. So we're really not reinventing the Turner River water wheel. We're only trying to apply some BMPs and SOPs to make it better. So here's the Turner River delivery system. Current is 2 sets of culverts and 1 eroded 15-foot canal plug. And our proposed is 5 sets of culverts and 5 150 to 250 foot wetland grade plugs. Here's an overview map of the project. Current condition and proposed condition. Anywhere the culverts are green, that means it's a new culvert going in. The white ones are the pre-existing culverts, and the red dashes are the plugs. And here's the design logic. Here's the before condition, and here's our proposed condition with the longer plug. As water moves down, on the old condition, water bypassed around the plug. On the new condition, we're sending water into the wetland. Here's some design details. We want to create 5 culvert plug pairs by infilling those 5 sections, and then we want to add 3 new sets of 24-inch diameter culverts, having it a double barrel at each culvert site. That's the standard treatment. Some more design details. Here's the plug. Again, we're going to fill the plug into wetland grade. We're not going to make the plug the height of the existing road surface. There's no reason to do that. Here's some design, some more design work. The PowerPoint's also going to be separately included if you want to review that in more detail. Just some more design sketches. And then here we go through a detailed maps of the 5 culvert plug pair locations. We're calling them T1 through T5. T1 and T4 have the existing culverts. Here's the T1 overview map. Here's where the lengthen at that site, we're just lengthening the plug. At T2, we're going to be adding a new culvert and a new plug. At T3, we're going to be adding a new culvert and a new plug. At T4, the culvert already exists. We're going to be adding a new plug. And at T5, it's going to be, again, a new culvert and a new plug. This is all flowing water into National Park Service land. No private property or other drainage issues are expected to occur as a result. And we're looking at this as a partnership project between Big Cypress and Collier County and South Florida National Parks Trust, who is using, we've been awarded $60,000 on this project. Implementation, there's just a few points on implementation. The NEPA compliance is covered under the Big Cypress National Preserve's 1991 General Management Plan. Collier County has the municipal privilege to install culverts under its rural road network, which Turner River Road is, and then canal infilling of the aspect. Now, we find that the entire project, just not the canal infilling, will require a permit. Our culvert choices were a box culvert, concrete culverts, or high density polyethylene pipe. And to make a long story short, the HDPE pipe was the way to go, not only because we can partner with the county on it, but the cost of the material is much reduced, and it's in a very effective way to send water across the road. So our plug choices then, we're getting free dirt from the county stockpile or free dirt from the Boise stockpile. The big difference is our stockpile is closer, and when we went through all the math on this, total truckloads are 400. So to ship the dirt in from the county stockpile is almost $100,000 compared to under $20,000 for using the local supply. So that's the obvious choice there. So a cost summary for this project, we're going to use the HDPE pipe. We're looking to partner with Collier County. We're going to use between 6,000 and actually 8,000 cubic yards of locally stockpiled fill dirt. We're going to probably contract out trucking the dirt to each plug site, and we're going to look into installing the plugs using our internal staff and equipment. Again, this is kind of a general cost breakdown as presented at the January 28th meeting. So our anticipated results of this project are to increase the flow rate and seasonal duration of water in the Turner River, to increase the depth and duration of surface water in wetlands on the west side of Turner River Road. We're going to create some new wetland with those plugs, and create a more sustainable and maintenance-friendly Turner River water delivery system. We're going to do a better job at preventing road overtopping during those peak rain events. Sometimes that happens on Turner River Road, and this will help alleviate that. But most of all, our pie-in-the-sky goal here is to help make the Turner River more navigable for canoeing and kayaking. It's frustrating to see this channel not navigable in its headwaters because of the vegetation that's the submerged aquatic vegetation, and this is one way to help get the river in a more open channel, sustainable way. And in closing, that's the big topic presented to the team. What do we do today to keep this project on track? And I think we're doing that. So thank you for your time on this project, and I hope having this in audio version helps everyone for reference. Thank you.